Right now, as you absorb these words, something unprecedented is moving through our solar system. An object so ancient it witnessed the birth of galaxies, carrying secrets from a stellar nursery that died billions of years before our sun even existed. Yet as we prepare to meet this cosmic stranger, one question haunts the scientific community. Are we greeting a messenger from the deep past, or have we stumbled upon something that challenges everything we thought we knew about visitors from beyond? Take a breath and let that reality settle into your awareness. In the vastness of space, where distances are measured in the time it takes light to travel, genuine visitors from other star systems are vanishingly rare. We've confirmed only 3 in all of human history, and now the third has arrived. Its name is 3I/ATLAS, and it's unlike anything we've encountered before. On July 1st, 2025, an automated telescope in Chile's Atacama Desert captured something extraordinary, disguised as an ordinary point of light. The Asteroid Terrestrial Impact Last Alert System, appropriately acronymed ATLAS, had been scanning the night sky with mechanical precision when it detected an object moving against the stellar background. Initially catalogued as just another potential near-Earth asteroid, this faint smudge would soon rewrite our understanding of what travels between the stars. The first hint that this discovery was special came from the mathematics. As astronomers refined the object's trajectory over the following days, one parameter stood out with startling clarity. Its orbital eccentricity exceeded unity. In the language of celestial mechanics, this is the unmistakable signature of a hyperbolic trajectory, an orbit carrying more than enough velocity to escape our sun's gravitational influence entirely. This object wasn't bound to our solar system, it was just passing through. The designation 3I tells its own profound story. The I stands for interstellar, while the number 3 indicates this is only the third such confirmed visitor in human history. Its predecessors, 1I/Oumuamua in 2017 and 2I/Borisov in 2019, had each surprised astronomers with characteristics that defied easy categorization. Now 3I/ATLAS continues this pattern of interstellar unpredictability, but on a scale that dwarfs both of its predecessors. Consider the velocity. When discovered, this interstellar wanderer was traveling at approximately 137,000 miles per hour, or 61 kilometers per second, relative to our Sun. To put this in perspective, Earth maintains its stable orbit around our star at roughly 30 kilometers per second. 3I/ATLAS carries more than twice the kinetic energy of our entire planet's orbital motion, accumulated during what may be billions of years of travel through the galaxy. As you contemplate this, notice how the scale begins to shift your perspective on cosmic time and distance. This object has been journeying through space longer than complex life has existed on Earth. What makes 3I/ATLAS truly extraordinary isn't just its interstellar origin, but its bewildering size. Initial estimates suggested a nucleus somewhere between 440 meters and 5.6 kilometers in diameter, already placing it among the larger objects of its type. But as observations continued, something unprecedented emerged from the data. Recent analysis suggests the object may be dramatically larger than initially estimated. Some measurements hint at a nucleus diameter of 46 kilometers with a mass exceeding 33 billion tons. If confirmed, this would make 3I/ATLAS roughly 1,000,000 times more massive than the previous interstellar comet, 2I/Borisov. The implications of this size are staggering and deeply troubling for our current understanding of interstellar object populations. According to theoretical models of how planetary systems form and eject debris, we should encounter thousands of smaller interstellar objects before detecting even one of this magnitude. Yet 3I/ATLAS represents only our third confirmed interstellar visitor. Harvard astronomer Avi Loeb has described this as a major anomaly, noting that given the limited reservoir of heavy elements in the galaxy, we should have discovered approximately 100,000 objects on the scale of Oumuamua before finding something as massive as 3I/ATLAS. The statistics simply don't align with our expectations of how matter distributes itself between star systems. This size controversy touches on fundamental questions about the nature of reality itself. Are we witnessing a statistical fluke, or does the presence of 3I/ATLAS suggest gaps in our understanding of galactic evolution and material exchange between stellar systems? The true wonder of 3I/ATLAS reveals itself through spectroscopic analysis, the technique that allows astronomers to decode the chemical fingerprints of distant objects. When the James Webb Space Telescope and other advanced instruments turned their attention to this interstellar visitor, they discovered something remarkable, a composition unlike anything in our solar system. The object's coma, the cloud of gas and dust surrounding its nucleus, extends approximately 350,000 kilometers into space. This ghostly atmosphere consists primarily of carbon dioxide, accounting for 87% of the detected material by mass. Carbon monoxide makes up another 9%, with water comprising most of the remaining 4%, along with traces of cyanide, and most intriguingly, nickel vapor. This chemical signature tells a story of formation in conditions radically different from our local cosmic neighborhood. The dominance of carbon dioxide over water vapor suggests this object condensed in the frigid outer regions of its parent star system, far beyond what astronomers call the carbon dioxide snowline, where temperatures remain low enough for CO2 to freeze into solid ice. Most comets in our solar system show water as their primary volatile component, with carbon dioxide playing only a secondary role. The reversed ratio in 3I/ATLAS indicates formation temperatures and pressures unlike anything experienced by objects native to our stellar vicinity. The presence of nickel vapor is particularly fascinating and unusual. While nickel exists in many cosmic objects, its detection in the gaseous state around a comet nucleus suggests either unique formation conditions or processes not commonly observed in our solar system's population of small bodies. As you absorb this information, consider what it means to hold direct evidence of chemistry that occurred in another star system, potentially billions of years ago. Every molecule detected in 3I/ATLAS's coma represents a preserved sample from stellar conditions that may no longer exist anywhere in the galaxy. Perhaps the most extraordinary aspect of 3I/ATLAS is its estimated age, which may make it the oldest known object ever observed by human science. Trajectory analysis and stellar population studies suggest this wanderer originated from the Milky Way's thick disk, a population of ancient stars formed during our galaxy's youth. The thick disk represents stars that condensed from primordial gas when the universe was fundamentally different from today. Star formation rates were higher, heavy element abundances were lower, and the galactic environment was more chaotic and violent. Objects ejected from these ancient systems carry within their structure the chemical signatures of cosmic conditions that existed when our galaxy was still young and actively growing. Current estimates place 3I/ATLAS's age between 7.6 and 14 billion years, with some analyses suggesting it could be as old as 11 billion years. If confirmed, this would mean the object has been wandering through interstellar space since before our Sun existed, surviving cosmic radiation, gravitational perturbations from passing stars, and the harsh environment of the galactic medium. Think about this temporal scale for a moment. While Earth was forming from the debris of our nascent solar system 4.6 billion years ago, 3I/ATLAS was already an ancient traveller, carrying chemical information from stellar processes that occurred when the universe was less than a quarter of its current age. This ancient heritage transforms 3I/ATLAS from merely an unusual comet into something approaching a time capsule from cosmic dawn. Its chemical composition preserves information about stellar nucleosynthesis, planetary formation processes, and galactic chemical evolution from an epoch we can study no other way. The path 3I/ATLAS follows through our solar system, reveals crucial information about its origins and the forces that shaped its billion-year journey through space. When astronomers break down its hyperbolic excess velocity into galactic coordinate components, they discover an object moving away from the galactic center with a velocity of negative 51 kilometers per second relative to our Sun, while simultaneously moving upward through the galactic plane at positive 18.5 kilometers per second. This velocity profile serves as a cosmic fingerprint, encoding information about the gravitational environment where 3I/ATLAS began its interstellar journey. The specific combination of speeds and directions points toward ejection from a stellar system within the thick disk population, consistent with the age estimates derived from chemical analysis. But the trajectory also reveals the object's future. Following its current path, 3I/ATLAS will make its closest approach to our Sun on October 30th, 2025, at a distance of approximately 1.4 astronomical units, just inside Mars's average orbital radius. This perihelion passage will subject the ancient wanderer to solar radiation intensities unlike anything it has experienced during its interstellar voyage. The timing creates both opportunity and challenge for scientific observation. As 3I/ATLAS approaches its solar encounter, it will become increasingly difficult to observe from Earth due to its proximity to the Sun in our sky. Solar conjunction, the period when the object appears too close to our star for practical observation, will hide the comet during what may be its most active and revealing phase. Yet before this observational blackout occurs, 3I/ATLAS will pass remarkably close to Mars on October 3rd, 2025, at a distance of just 28 million kilometers. This encounter represents a unique opportunity for spacecraft orbiting the red planet to capture detailed images and spectra of an interstellar object visitor, potentially resolving some of the fundamental questions about its true nature and size. As you listen, notice how this cosmic choreography unfolds with precise mathematical beauty, yet carries within it elements of mystery that may never be fully resolved. The approach of 3I/ATLAS toward our inner solar system marks more than just another astronomical event. It represents humanity's encounter with tangible evidence of processes that occurred in stellar environments we may never visit, carrying chemical signatures from an epoch when the galaxy itself was fundamentally different. Whether this ancient wanderer proves to be simply an unusually large and old comet, or something that challenges our current understanding of interstellar objects, its presence in our solar system offers a rare opportunity to study authentic samples from cosmic deep time. But as we prepare for its closest approach to our Sun, questions multiply faster than answers. Why haven't we detected more objects like this before? What does its unusual size distribution tell us about planetary formation throughout the galaxy? And most intriguingly, what secrets might it reveal during its hidden passage behind solar glare? The story of 3I/ATLAS is just beginning to unfold, and what we discover in the coming months may transform our understanding of what wanders between the stars. As October approaches, 3I/ATLAS prepares for what may be the most scientifically crucial moments of its entire solar system passage. The close encounter with Mars on October 3rd represents more than just a celestial coincidence. It offers humanity's best opportunity to peer directly at an authentic piece of another star system, while Earth-based telescopes still maintain visual contact. The geometry couldn't be more fortuitous. As this ancient wanderer sweeps past Mars at a distance of 28 million kilometers, multiple spacecraft orbiting the red planet will turn their mechanical eyes toward our interstellar visitor. The Mars Reconnaissance Orbiter, with its high-rise camera, capable of resolving surface features smaller than a meter across, will attempt to capture images of 3I/ATLAS's nucleus with unprecedented clarity. For a brief window, these robotic sentinels will serve as humanity's ambassadors to the deep past, documenting an object that has travelled farther and longer than any human-made probe ever will. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter will contribute their own observations, creating a coordinated surveillance network focused on this cosmic time capsule. Yet even as these observations unfold, a more profound mystery deepens. Why does an object this massive exist at all in the interstellar medium? Take a moment to consider the statistical impossibility of what we're witnessing. According to our best models of planetary formation and gravitational ejection processes, large objects, like 3I/ATLAS, should be extraordinarily rare compared to their smaller counterparts. We should encounter thousands of boulder-sized interstellar fragments before detecting even 1-kilometer-scale object, let alone something potentially tens of kilometers across. The fact that our third confirmed interstellar visitor happens to be orders of magnitude more massive than its predecessors challenges fundamental assumptions about how matter distributes itself throughout the galaxy. Either we've witnessed an extraordinary statistical coincidence, or our understanding of interstellar object populations contains significant gaps. This discrepancy has prompted some researchers to explore alternative explanations for 3I/ATLAS's nature and origin. While the overwhelming scientific consensus supports its identification as a natural comet, the object's unusual characteristics have generated speculation about whether we're dealing with something more exotic than previously encountered. In the careful, measured world of astronomy, few topics generate as much debate as the possibility that an observed object might be of artificial origin. Harvard astronomer Avi Loeb, who previously suggested that Oumuamua might represent alien technology, has now turned his attention to 3I/ATLAS with similar speculation. Loeb has proposed what he calls the Loeb scale for interstellar objects, ranging from 0 for definitively natural objects to 10 for definitively technological ones. He currently assigns 3I/ATLAS a rating of 6, indicating significant uncertainty about its true nature, while acknowledging that additional data could shift this assessment in either direction. The basis for such speculation rests not on direct evidence of technology, but rather on the statistical anomalies surrounding the object's discovery and characteristics. The extreme rarity of finding such a massive interstellar object, combined with its unusual chemical composition and trajectory, creates what Loeb describes as a pattern requiring explanation. However, it's crucial to understand that this represents a minority position within the astronomical community. Multiple independent research teams using different telescopes and analytical methods have concluded that 3I/ATLAS exhibits all the expected properties of an interstellar comet. Its coma formation, outgassing behavior, and spectroscopic signatures match theoretical predictions for how such objects should behave when heated by solar radiation. As you reflect on this debate, notice how it illustrates the tension between maintaining scientific skepticism and remaining open to unexpected possibilities. The history of astronomy is filled with phenomena that initially seemed impossible or artificial, but later received natural explanations as our understanding deepened. The approaching solar conjunction period presents both the greatest scientific opportunity and the most frustrating observational challenge of the entire 3I/ATLAS encounter. As the object approaches its closest point to our Sun on October 30th, it will simultaneously disappear behind solar glare from Earth's perspective, creating a month-long blackout when ground-based telescopes cannot track its behavior. This timing represents a cosmic irony of extraordinary proportions. Just as 3I/ATLAS experiences the most intense solar heating of its billion-year journey, potentially triggering dramatic outgassing events and revealing subsurface materials preserved since its formation, human observers will be effectively blind to these transformations. The perihelion distance of 1.4 astronomical units places the comet closer to our Sun than it has been to any star in millions or billions of years. Solar radiation at this distance carries enough energy to sublimate volatile compounds that have remained stable throughout the object's interstellar voyage, potentially creating spectacular displays of coma expansion and tail development. Theoretical models predict that this intense heating could drive gas production rates far exceeding those typical of solar system comets. The carbon dioxide-rich composition detected in 3I/ATLAS's coma should respond dramatically to increased temperature, possibly creating outgassing events visible across the entire inner solar system. Yet all of this activity will occur hidden from direct human observation, preserved only in whatever indirect evidence survives for later analysis when the comet re-emerges from solar glare in early December. Consider what this means for our understanding of interstellar chemistry and physics. We're witnessing the activation of materials that have remained chemically inert for longer than complex life has existed on Earth. For the first time since its ejection from an ancient stellar system, 3I/ATLAS will experience conditions capable of driving significant chemical and physical changes. The timing of 3I/ATLAS's arrival coincides with a revolution in astronomical survey capabilities that may fundamentally change how we detect and study interstellar visitors. The Vera C. Rubin Observatory, currently completing its commissioning phase in Chile, represents the most powerful sky survey instrument ever constructed. In just 10 hours of initial operation, Rubin Observatory discovered over 2,000 previously unknown asteroids in our solar system, including 7 near-Earth objects. Once fully operational, this facility alone will discover millions of new small bodies within its first 2 years of operation, dramatically expanding our census of solar system populations. More significantly for interstellar object research, Rubin Observatory's unprecedented survey speed and sensitivity could detect up to 70 interstellar objects, visitors annually once it reaches full capacity. This represents a potential increase of more than an order of magnitude over current discovery rates. The implications extend far beyond simple numbers. If interstellar objects prove to be as common as these projections suggest, the era of studying individual visitors, like 3I/ATLAS, as rare curiosities may be ending. Instead, we may be entering a period where systematic population studies become possible, allowing astronomers to characterize the full diversity of materials and formation processes throughout the galaxy. As you contemplate this transformation, notice how technological advancement continuously reshapes our relationship with cosmic phenomena. What seems extraordinarily rare from our current perspective may prove commonplace once our observational capabilities expand. The story of 3I/ATLAS illuminates fundamental questions about the nature of matter, time, and cosmic evolution that extend far beyond the specifics of any single object. Each measurement and observation contributes to broader inquiries about how galaxies evolve, how planetary systems form and interact, and what kinds of information can survive the journey between star systems. The chemical signatures preserved in this ancient wanderer provide direct evidence about stellar nucleosynthesis processes that occurred when the universe was dramatically younger and more active than today. The ratios of different elements and isotopes encode information about the mass, temperature, an evolutionary state of the star system where 3I/ATLAS formed. But perhaps more intriguingly, the object's survival of a billion-year interstellar journey demonstrates the remarkable stability of certain chemical and physical structures across cosmic timescales. The nickel vapor detected in its coma suggests that complex metallurgical processes can remain preserved through conditions of extreme cold, radiation exposure, and gravitational perturbation. This preservation of chemical information across galactic distances opens possibilities for a new form of archaeology, the study of ancient stellar environments through the analysis of their ejected debris. Each interstellar visitor potentially carries samples from stellar conditions that no longer exist anywhere in the observable universe. The trajectory analysis that places 3I/ATLAS's origin in the galactic thick disk connects this individual object to broader questions about galactic chemical evolution and the distribution of heavy elements throughout cosmic history. If confirmed, this would mean we're studying materials formed when the galaxy's star formation rate was higher and its chemical composition fundamentally different from today. Take a breath and consider what it means to hold direct physical evidence of processes that occurred billions of years before our solar system existed. In studying 3I/ATLAS, we're not merely observing an unusual comet, we're conducting forensic analysis of cosmic history itself. The questions raised by this interstellar visitor will likely persist long after the object itself has departed our solar system. Whether future observations confirm its classification as an unusually large and ancient comet, or reveal characteristics that challenge current theoretical frameworks. 3I/ATLAS has already succeeded in expanding the boundaries of what we consider possible for objects wandering between the stars. As we prepare for its hidden passage behind solar glare and eventual re-emergence in December, the deeper mystery remains. What other messengers from cosmic deep time are already travelling toward our solar system, carrying their own preserved samples from stellar environments we can study no other way? The universe, it seems, has found a way to deliver its own time capsules directly to our telescopes. The question is whether we possess the wisdom and patience to read the messages they contain. But the story of 3I/ATLAS connects to even deeper questions about consciousness, observation, and humanity's role as witnesses to cosmic phenomena. If you're ready to explore how the act of scientific discovery itself might be woven into the fabric of reality in ways that challenge our understanding of observation and measurement, then I invite you to continue this journey with our previous exploration. We asked the universe the big questions and got terrifying answers. As 3I/ATLAS continues its ancient journey toward perihelion, something remarkable unfolds in the relationship between observer and observed. This interstellar wanderer has become the focus of one of the most comprehensive observational campaigns in astronomical history, with dozens of telescopes, spacecraft, and research teams coordinating their efforts across multiple continents and orbital positions. The European Space Agency has mobilized an unprecedented array of assets for this encounter. Mars Express, ExoMars Trace Gas Orbiter, and the Jupiter Icy Moons Explorer will all train their instruments on this cosmic visitor. NASA's contribution includes observations from Hubble, Webb, the Transiting Exoplanet Survey Satellite, SWIFT, SPHERE-X, and even Mars rovers Perseverance and Curiosity, along with the Parker Solar Probe and dozens of other missions scattered throughout the solar system. As you absorb this information, notice how the act of observation itself has become a planetary endeavor. Humanity has created a distributed network of mechanical eyes and analytical instruments that can track a single object across hundreds of millions of kilometers, extracting chemical signatures and physical properties from reflected photons that have traveled vast distances to reach our detectors. This coordinated surveillance raises profound questions about the nature of scientific observation and the relationship between consciousness and cosmic phenomena. When dozens of instruments simultaneously focus on a single object, are we simply gathering data, or are we participating in something more fundamental about how information flows through the universe? The quantum mechanics that govern atomic and molecular interactions suggest that observation itself plays a role in determining the state of observed systems. While these effects typically manifest only at microscopic scales, some interpretations suggest that the boundary between observer and observed may be more fluid than classical physics assumes. Consider what it means that 3I/ATLAS has travelled billions of years through the galaxy without being observed by any conscious entity, only to arrive at our solar system during the precise historical moment when humanity has developed the technological capability to detect and analyse its properties. The timing seems almost too convenient to be purely coincidental. The arrival of 3I/ATLAS during humanity's brief technological adolescence raises questions that extend beyond astronomy into realms of meaning and purpose that science struggles to address. This object formed around another star when our galaxy was young, travelled through interstellar space longer than complex life has existed on Earth, and arrived precisely when we possess the instruments necessary to study it. If 3I/ATLAS had appeared even a century earlier, we would have dismissed it as another fuzzy star, lacking the spectroscopic capabilities to recognise its true nature. A century later, our observations might be so routine and automated that we would catalogue its properties without appreciating the profound implications of its presence. The window of wonder, that narrow band of technological capability, combined with conscious appreciation for cosmic mystery, seems almost deliberately aligned with this ancient visitor's arrival. Some interpretations suggest this reflects deeper patterns in how information and consciousness interact on galactic scales, though no scientific consensus exists for such speculative ideas. As you listen, allow yourself to feel the weight of this temporal coincidence. What does it mean to live at the precise moment when humanity can first recognize and study authentic messengers from other star systems? Are we witnessing random chance or participating in something more purposeful about how awareness and cosmic phenomena align? The philosopher Pierre Teilhard de Chardin spoke of the noosphere, a sphere of human consciousness that increasingly influences planetary processes. In studying 3I/ATLAS, we're extending this sphere of awareness to encompass objects that originated light years away and billions of years ago. We're becoming conscious witnesses to cosmic evolution itself. Every measurement of 3I/ATLAS's chemical composition provides a glimpse into stellar processes that occurred when the universe was fundamentally different from today. The carbon dioxide that dominates its coma condensed in the frigid outer regions of an ancient star system. The nickel vapor detected in its atmosphere formed through nucleosynthesis in stellar cores that died before our sun was born. These chemical signatures serve as a kind of cosmic mirror, reflecting conditions in stellar environments we can never visit directly. But they also reflect something about consciousness itself, our capacity to decode information preserved across impossible distances and timescales. The act of spectroscopic analysis transforms reflected photons into chemical knowledge. Light that left 3I/ATLAS's coma carries within its wavelength patterns the fingerprints of molecular vibrations and electronic transitions. When this light reaches our detectors, sophisticated algorithms translate these patterns back into chemical identities and abundances. Take a breath and consider the chain of causation involved. Stellar nucleosynthesis billions of years ago created the heavy elements now sublimating from 3I/ATLAS's nucleus. Solar heating today drives these materials into gaseous form. Molecular interactions absorb and emit photons at characteristic frequencies. These photons travel millions of kilometers to reach our instruments. Digital sensors convert light into electrical signals. Computer algorithms process these signals into spectroscopic data. Human consciousness interprets this data as chemical knowledge. At each step, information flows from one form to another, creating an unbroken chain connecting ancient stellar processes to present human understanding. We are, in a very real sense, thinking the thoughts of stars that died before Earth existed. As comprehensive as our observational campaign has become, 3I/ATLAS will soon disappear behind solar glare for nearly a month, creating an enforced period of ignorance during what may be its most revealing phase. This observational gap serves as a humbling reminder of the limits inherent in all human knowledge. The approaching solar conjunction represents more than a technical challenge. It embodies the fundamental constraints that govern scientific observation. We can extend our senses through sophisticated instruments and coordinate observations across planetary distances, but we remain bound by the physical laws that determine what can and cannot be directly observed. During perihelion, 3I/ATLAS will experience conditions that haven't affected its structure in millions or billions of years. Volatile compounds preserved in its nucleus since formation may sublimate for the first time. Internal stresses from rapid heating could cause structural changes or even fragmentation. New chemical species might appear as solar radiation breaks down complex organic molecules. All of these potentially dramatic transformations will occur beyond the reach of direct human observation. We will be forced to infer what happened from whatever evidence remains when the comet re-emerges from solar glare in December. This forced ignorance mirrors deeper epistemological questions about the nature of knowledge itself. How much of reality unfolds beyond the reach of conscious observation? What transformations occur in the vast spaces between our instruments and our awareness? Some interpretations of quantum mechanics suggest that unobserved events exist in superposition states until measurement collapses them into definite outcomes. While this principle typically applies only to microscopic systems, metaphorically speaking, the hidden transformations of 3I/ATLAS during solar conjunction might exist in a similar state of uncertainty until observation becomes possible again. The study of 3I/ATLAS has become a remarkably democratic endeavour, with amateur astronomers around the world contributing observations alongside professional research teams. Backyard telescopes, equipped with modern CCD cameras, can detect this interstellar visitor and track its brightness variations, adding valuable data points to the global monitoring effort. This democratization of cosmic discovery represents a profound shift in how scientific knowledge develops. Professional observatories provide the most sophisticated spectroscopic and imaging capabilities, but dedicated amateur observers often contribute the continuous monitoring necessary to catch rapid changes or unexpected events. As you reflect on this collaborative approach, notice how the boundaries between professional and amateur, expert and enthusiast become less important when facing phenomena that exceed any individual's capacity to fully comprehend. The study of interstellar objects requires a planetary effort that transcends institutional divisions. The Internet has transformed this collaboration from a loose network of correspondence into a real-time global observatory. Images and measurements can be shared instantly, allowing rapid response to unexpected developments. When 3I/ATLAS begins its re-emergence from solar conjunction in December, hundreds of telescopes worldwide will be ready to document its transformation. This distributed approach to observation mirrors deeper principles about how consciousness and awareness scale across different levels of organization. Individual observers contribute unique perspectives and capabilities, but the collective effort generates understanding that exceeds the sum of its parts. The story of 3I/ATLAS inevitably leads to questions about consciousness and its relationship to cosmic phenomena that push beyond the boundaries of established science. While we can measure the object's chemical composition and track its trajectory with mathematical precision, the deeper question of why conscious beings exist to observe such phenomena remains tantalizingly unanswered. The fine-tuning of physical constants that allows complex chemistry and stable stellar evolution seems almost perfectly calibrated to permit the emergence of observers capable of studying cosmic evolution. The carbon and oxygen that form the basis of terrestrial biology were synthesized in stellar cores, similar to whatever star system ejected 3I/ATLAS billions of years ago. Some interpretations suggest this represents more than coincidence, that consciousness and cosmos may be more intimately connected than materialist science typically assumes. However, this remains a speculative idea without scientific consensus, touching on questions that may lie beyond the reach of empirical investigation. The anthropic principle offers one framework for thinking about these connections. In its weak form, it simply observes that we find ourselves in a universe capable of supporting conscious observers because we could not exist in any other kind of universe. The strong version suggests that the universe must have properties that allow consciousness to develop. Neither formulation provides definitive answers, but both highlight the remarkable fact that the universe has become aware of itself through conscious beings capable of studying its own history and evolution. Take a moment to feel the weight of this realization. In studying 3I/ATLAS, you are participating in the universe's capacity for self-reflection. The atoms in your brain were forged in stellar cores similar to those that created the materials now sublimating from this interstellar comet. You are quite literally star stuff contemplating star stuff. Despite decades of advancing technology and increasingly sophisticated theoretical frameworks, objects like 3I/ATLAS continue to surprise us with characteristics that challenge our understanding of cosmic evolution. The statistical anomaly of finding such a massive interstellar object among only our third confirmed visitor suggests that either we've witnessed extraordinary luck, or our models of galactic material distribution need fundamental revision. This persistence of mystery in the face of advancing knowledge reflects something essential about the nature of scientific discovery. Each answer generates new questions, each measurement reveals additional complexities, each theoretical framework illuminates previously unrecognized depths of ignorance. The history of astronomy is filled with phenomena that initially seemed impossible or artificial, but later received natural explanations as understanding deepened. Pulsars were briefly considered possible signals from extraterrestrial civilizations before being identified as rapidly rotating neutron stars. Quasars appeared impossibly energetic until supermassive black holes provided adequate energy sources. Yet the pattern also includes discoveries that genuinely revolutionized our understanding of reality itself. The expansion of the universe, dark matter, dark energy, and quantum mechanics all began as observations that didn't fit existing theoretical frameworks, and ultimately required new ways of thinking about space, time, matter, and causation. As you consider 3I/ATLAS and its unusual characteristics remain open to both possibilities. Most likely, continued observation and analysis will reveal natural explanations for its anomalous properties within existing physical frameworks, but the remote possibility remains that this ancient wanderer carries information that could reshape our understanding of how matter and consciousness interact on cosmic scales. The intensive study of 3I/ATLAS raises subtle questions about the ethics of scientific observation and our responsibilities as conscious witnesses to cosmic phenomena. This object has travelled unobserved through interstellar space for billions of years, following the laws of physics in perfect solitude. Our detection and analysis represent the first time in its existence that any conscious entity has focused attention on its properties and behavior. Does observation carry responsibility? When we track 3I/ATLAS with dozens of instruments and publish detailed analyses of its chemical composition, are we simply gathering scientific data, or are we participating in something more intimate about how consciousness relates to the objects of its attention? These questions may seem abstract, but they connect to practical concerns about how we approach the study of cosmic phenomena. The mechanistic worldview that has driven scientific progress for centuries treats objects like 3I/ATLAS as collections of matter following deterministic laws. But quantum mechanics suggests that the boundary between observer and observed may be more fluid than classical physics assumed. Some interpretations propose that consciousness plays an active role in determining the properties of observed systems, though these ideas remain highly speculative and lack scientific consensus. Even within purely materialist frameworks, the act of observation requires energy exchange between measuring instruments and observed objects, creating subtle but real interactions. As humanity's observational capabilities expand through projects like the Vera Rubin Observatory, we will detect increasing numbers of interstellar visitors. Each object will become the focus of intensive study, spectroscopic analysis, and theoretical modeling. We are becoming a species that systematically observes and catalogues cosmic phenomena on an unprecedented scale. This expansion of observational reach carries with it an expansion of responsibility. We are the conscious component of a universe becoming aware of its own complexity and beauty. The quality of attention we bring to phenomena, like 3I/ATLAS, may matter in ways we don't yet understand. The technological revolution represented by facilities like the Vera Rubin Observatory promises to transform our relationship with interstellar objects from studying rare curiosities to conducting systematic population surveys. If projections prove accurate, we may soon be detecting dozens of visitors like 3I/ATLAS annually, creating opportunities for comparative studies that could revolutionize our understanding of galactic evolution. This transition from scarcity to abundance will fundamentally change how we approach interstellar object research. Instead of mobilizing global resources to study individual visitors, we may develop automated systems capable of characterizing multiple objects simultaneously. Machine learning algorithms could identify patterns and anomalies across large datasets, potentially revealing trends invisible in individual case studies. As you imagine this future, notice how technological advancement continuously reshapes the boundary between the known and unknown. What seems mysterious and unique from our current perspective may become routine and predictable once sufficient data becomes available. Yet abundance brings its own challenges. How do we maintain the sense of wonder and careful attention that objects like 3I/ATLAS deserve when they become common rather than extraordinary? How do we prevent the automation of discovery from disconnecting us from direct engagement with cosmic phenomena? The democratization of access in scientific research as automation becomes more prevalent. The questions interstellar objects or contribute to classification efforts, the offers one path forward. When anyone with participation in cosmic discovery may prove essential for maintaining the human element. Internet access can examine spectroscopic data to astronomical data through online archives and citizen science platforms. Boundary between professional and public engagement begins to dissolve. This broader that drive meaningful investigation. Why does this matter? What does it mean? How does it connect to deeper patterns? Require conscious reflection that cannot be fully automated. As 3I/ATLAS approaches its hidden passage behind solar glare, we confront the cyclical nature of cosmic observation and the eternal return of mystery despite advancing knowledge. This ancient wanderer will emerge from conjunction, transformed by its encounter with solar radiation, potentially revealing new characteristics while concealing others beneath the changes wrought by intense heating. The pattern reflects broader themes about knowledge and ignorance, revelation and concealment that permeate both scientific discovery and conscious experience. Each answer generates new questions. Each measurement reveals previously unrecognized complexities. Each theoretical framework illuminates unexplored territories of understanding. In studying 3I/ATLAS, we participate in an ancient human activity, watching the sky and seeking meaning in celestial phenomena. Our instruments have become vastly more sophisticated, our theoretical frameworks more mathematically precise. But the fundamental act remains unchanged. We are conscious beings attempting to understand our place in a cosmos that consistently exceeds our capacity to fully comprehend it. The chemical signatures preserved in this interstellar visitor connect us directly to stellar processes that occurred when the universe was young. Every molecule in its coma carries information about nuclear synthesis, planetary formation, and galactic evolution from epochs we can study no other way. But beyond the scientific data lies a deeper mystery about the nature of information itself, and how it flows between cosmic phenomena and conscious observation. The photons that carry spectroscopic signatures from 3I/ATLAS to our instruments bridge vast distances and timescales, creating direct physical connections between ancient stellar processes and present human awareness. Take a breath and feel yourself participating in this cosmic conversation. The atoms in your body were forged in stellar cores similar to those that created 3I/ATLAS billions of years ago. The light reaching your eyes carries information that originated in nuclear reactions occurring throughout the galaxy's evolution. You are simultaneously observer and observed, studying phenomena that share your ultimate cosmic heritage. As this ancient wanderer continues its journey towards solar conjunction and eventual re-emergence, it carries with it questions about consciousness, observation, and meaning that extend far beyond astronomy into the deepest philosophical territories human thought can explore. The universe has doorstep a messenger delivered to hour from cosmic deep time, preserved across impossible distances and durations to arrive precisely when we possess the capability to study it. Whether this represents extraordinary coincidence or hints at deeper patterns in how awareness and cosmic phenomena align remains an open question that may persist long after 3I/ATLAS has departed our solar system. But perhaps the persistence of mystery is itself the most important lesson this interstellar visitor offers. In a cosmos where conscious beings can study authentic samples from other star systems, where ancient stellar processes become accessible to present understanding, and where the boundaries between observer and observed blur at quantum scales, the capacity for wonder and questioning may be the most valuable human contributions to cosmic evolution. The story continues to unfold, carrying us deeper into territories where science and philosophy, knowledge and mystery, observation and participation converge in ways that challenge every assumption about the nature of reality and our place within it. As 3I/ATLAS vanishes into the solar glare that will conceal its most dramatic transformations, we encounter a profound paradox about the nature of scientific knowledge itself. This enforced period of ignorance during the comet's perihelion passage reveals something essential about how understanding emerges from the interplay between what we can observe and what remains forever hidden from direct measurement. The approaching conjunction creates what philosophers of science call an observation horizon, a boundary beyond which certain forms of knowledge become temporarily or permanently inaccessible. During the 4 weeks when 3I/ATLAS remains hidden behind our star's overwhelming brightness, the most significant changes in its structure and composition will unfold without conscious witnesses. This situation mirrors deeper questions about the relationship between reality and observation that have puzzled thinkers for centuries. The ancient philosophical question of whether a tree makes a sound when it falls in an empty forest finds new expression in the modern context of an interstellar comet undergoing transformation beyond the reach of human measurement. Some interpretations of quantum mechanics suggest that unobserved systems exist in superposition states until measurement collapses them into definite outcomes. While this principle typically applies only to microscopic phenomena, metaphorically speaking, the hidden transformations of 3I/ATLAS during conjunction might exist in a similar state of uncertainty until observation becomes possible again. Take a moment to consider what this means for your own relationship with the unknown. How much of your daily experience unfolds beyond the reach of conscious attention? What transformations occur in the vast spaces between your moments of focused awareness? The meditation traditions of various cultures have long explored this territory where observation and reality intersect. The practice of mindful attention reveals how much of ordinary experience passes unnoticed, while simultaneously demonstrating that the quality of awareness itself can influence what becomes available for conscious recognition. The study of 3I/ATLAS occurs within a framework of quantum mechanical principles that govern all atomic and molecular interactions, creating subtle but profound connections between the act of observation and the information that becomes available through measurement. While these quantum effects typically manifest only at microscopic scales, they establish the fundamental basis for all scientific observation, including the spectroscopic analysis that reveals the chemical composition of distant objects. When photons from 3I/ATLAS's coma interact with the atoms in our detectors, they create what physicists call quantum entanglement, a phenomenon where particles become correlated in ways that transcend classical notions of separate, independent objects. This remains a proven scientific fact that has been verified through countless experiments, though its implications for larger-scale phenomena remain speculative and lack scientific consensus. The information carried by these photons represents a direct physical connection between the ancient stellar processes that formed 3I/ATLAS and the present moment of human observation. Each wavelength pattern encodes specific molecular vibrations and electronic transitions that occurred millions of kilometers away, creating an unbroken chain of causation from interstellar chemistry to conscious understanding. As you reflect on this quantum foundation of knowledge, notice how it challenges conventional assumptions about the separation between observer and observed. The boundaries that seem so clear in everyday experience become more fluid when examined at the level of fundamental physical interactions. However, this is a speculative idea that extends beyond current scientific consensus. While quantum entanglement between particles is well established, whether these effects scale up to influence the relationship between consciousness and cosmic phenomena remains unproven and highly controversial among physicists. The light currently reaching us from 3I/ATLAS began its journey when the comet was millions of kilometers away, creating a temporal paradox where present observation reveals past states of a constantly changing object. The photons striking our detectors carry information about molecular conditions that existed in the comet's coma during earlier phases of its solar approach, not its current state. This delay between event and observation creates what astronomers call light-time lag, but it also represents something more profound about the nature of knowledge and temporal experience. Every act of observation involves receiving information from the past, whether we're looking at distant galaxies billions of years ago or reading words written moments before. The recognition of this temporal displacement can be deeply unsettling when fully contemplated. The 3I/ATLAS you think you're observing no longer exists in the form you're seeing. By the time light from its coma reaches Earth, the comet has moved to a new position, with potentially different chemical activity and physical characteristics. This same principle applies to all conscious experience. The neural processing that creates your sense of present awareness requires finite time, meaning that consciousness always lags slightly behind the events it seems to observe. The present moment, when examined closely, reveals itself to be a construction built from recently received information about the immediate past. Take a breath and notice how this realization might shift your relationship with the experience of now. If present awareness is always slightly delayed, what does this suggest about the nature of time and consciousness? Some meditation traditions have explored this temporal paradox through practices that investigate the constructed nature of present moment experience. These techniques often reveal how the sense of a solid continuous present dissolves under careful examination, replaced by a more fluid understanding of how awareness processes temporal information. The global coordination required to study 3I/ATLAS has created what might be called a planetary nervous system, a distributed network of instruments and human observers that functions as an extended sensory apparatus capable of perceiving phenomena across vast scales of space and time. This collaboration transcends national boundaries, institutional hierarchies, and the traditional divisions between professional and amateur investigation. When dozens of telescopes simultaneously track a single object, they create something analogous to compound vision in insects, where multiple simple eyes combine to generate sophisticated spatial and temporal perception. The data streams from different instruments merge into composite understanding that exceeds what any individual observatory could achieve alone. This distributed approach to observation mirrors principles found in biological nervous systems, where individual neurons contribute limited information that becomes meaningful only through collective processing. The parallel suggests that consciousness itself might be understood as an emergent property of information integration across multiple scales of organization. As you consider your own participation in this global effort to understand cosmic phenomena, notice how the boundaries between individual and collective awareness become less distinct. When you contemplate the chemical signatures detected in 3I/ATLAS's coma, you're participating in a form of distributed cognition that spans continents and includes both human consciousness and mechanical instrumentation. The internet has transformed this collaboration from a loose network of correspondence into a real-time planetary observatory. Spectroscopic data can be shared instantly, allowing rapid response to unexpected developments and creating opportunities for worldwide coordination that would have been impossible just decades ago. This technological enhancement of collective intelligence raises fascinating questions about the future evolution of consciousness and its relationship to cosmic observation. Some speculative interpretations suggest that we might be witnessing the emergence of a new form of awareness that operates at planetary scales, though this remains an unproven idea without scientific consensus. The arrival of 3I/ATLAS during the narrow window of human technological capability raises questions that extend into the realm of what philosophers call the anthropic principle, the observation that the universe's fundamental constants appear fine-tuned to permit the existence of conscious observers. While this principle has been applied primarily to cosmology and particle physics, the timing of interstellar visitor encounters suggests similar patterns might operate across different scales of cosmic evolution. Consider the remarkable chain of coincidences required for meaningful study of this ancient wanderer. 3I/ATLAS had to be ejected from its parent star system billions of years ago with precisely the right velocity and direction to arrive in our solar system. Earth had to evolve conscious beings capable of developing sophisticated technology. Human civilization had to advance to the point of building space telescopes and spectrographic instruments during the brief period of this object's passage through our cosmic neighborhood. If any element in this chain had been slightly different, if the comet had arrived a century earlier or later, if technological development had proceeded more slowly, if conscious observers had never evolved on Earth, the scientific revelations now unfolding would never have occurred. The chemical signatures from ancient stellar processes would have passed through our solar system unrecognized and unanalyzed. The anthropic principle offers one framework for thinking about such coincidences. In its weak form, it simply observes that we find ourselves in a universe capable of supporting conscious observers because we could not exist in any other kind of universe. The strong version suggests that the universe must have properties that allow consciousness to develop. Some interpretations extend this reasoning to propose that conscious observation plays an active role in determining cosmic evolution, though this remains a highly speculative idea that lacks scientific consensus. The timing of 3I/ATLAS's arrival might represent nothing more than extraordinary coincidence, or it might hint at deeper patterns in how awareness and cosmic phenomena align. Take a moment to feel the weight of your participation in this cosmic conversation. The atoms in your body were forged in stellar cores similar to those that created the materials now sublimating from 3I/ATLAS billions of years ago. You are simultaneously observer and observed, studying phenomena that share your ultimate cosmic heritage. The study of 3I/ATLAS reveals something profound about how information flows through cosmic systems, creating what might be understood as an ecology of knowledge that operates across impossible scales of space and time. Chemical signatures preserved in the comet's nucleus carry information about stellar nucleosynthesis processes that occurred when the galaxy was young. This information has survived billions of years of interstellar travel, cosmic radiation exposure, and gravitational perturbations to arrive in a form that human consciousness can decode and understand. The chain of information transfer involves multiple transformations that preserve meaning while changing form. Nuclear reactions in ancient stellar cores created specific isotopic ratios that became incorporated into planetary debris. Gravitational interactions ejected this debris into interstellar space. Solar heating now sublimes these materials into gaseous form. Molecular interactions absorb and emit photons at characteristic frequencies. These photons travel millions of kilometers to reach our detectors. Electronic sensors convert light into digital signals. Computer algorithms process these signals into spectroscopic data. Human consciousness interprets this data as chemical knowledge. Each transformation in this chain represents what information theorists call an encoding-decoding operation, where meaningful patterns persist despite changes in their physical substrate. The parallel to biological information transfer is striking. Genetic information flows from DNA to RNA to proteins through similar encoding-decoding steps that preserve meaning across different molecular forms. This suggests that the universe might be understood as fundamentally informational in nature, with matter and energy serving as carriers for more abstract patterns of organization and meaning. While this remains a speculative interpretation that extends beyond current scientific consensus, it offers a framework for understanding how consciousness and cosmos might be more intimately connected than materialist science typically assumes. As you contemplate this flow of information from ancient stellar cores to your present awareness, notice how the boundaries between different scales of organization become permeable. The distinction between cosmic and personal, ancient and present, physical and mental begins to dissolve under examination. The intensive observation of 3I/ATLAS has become a form of collective meditation, a sustained practice of attention that connects human consciousness to cosmic phenomena across vast scales of space and time. This comparison to contemplative practice isn't merely metaphorical. The quality of awareness brought to scientific observation shares essential characteristics with traditional meditation techniques. Both scientific observation and meditative awareness require sustained attention focused on phenomena that reveal their deeper nature only through patient, careful investigation. Both practices involve setting aside preconceptions and allowing reality to reveal itself through direct experience. Both require tolerance for uncertainty and the willingness to remain present with mystery rather than rushing toward premature conclusions. The spectroscopic analysis of 3I/ATLAS's chemical composition exemplifies this contemplative approach to knowledge. Each molecular signature must be identified through careful comparison with laboratory standards and theoretical predictions. Anomalous readings require patient investigation rather than immediate explanation. The chemical story that emerges unfolds gradually through accumulated observations rather than sudden revelation. This methodical approach to understanding parallels what meditation traditions call mindful investigation, the practice of examining experience with sustained attention until its deeper patterns become apparent. The parallel suggests that scientific discovery and contemplative insight might represent different applications of similar cognitive processes. Take a moment to notice the quality of attention you bring to understanding cosmic phenomena. How does focused awareness of 3I/ATLAS's ancient journey affect your sense of time and scale? What happens to your ordinary concerns when contemplating chemical processes that unfolded billions of years before Earth existed? Some research suggests that sustained attention to cosmic scales can produce what psychologists call self-transcendent experiences, moments when ordinary boundaries of identity expand to encompass larger contexts of meaning and connection. While the mechanisms underlying such experiences remain poorly understood, they appear to involve shifts in how consciousness processes information about scale, time, and identity. This is a speculative interpretation that lacks scientific consensus, but the subjective reports of many people engaged in astronomical observation suggest that sustained attention to cosmic phenomena can indeed produce profound shifts in perspective and understanding. Every chemical signature detected in 3I/ATLAS's coma reflects specific stages of stellar evolution that occurred in its parent system billions of years ago. The carbon dioxide that dominates its composition formed through nuclear fusion processes in stellar cores. The trace elements revealed through spectroscopic analysis record the death throes of massive stars that enriched their local environments with heavy elements before exploding as supernovae. This chemical record serves as a kind of fossil evidence for stellar processes that no longer exist anywhere in the observable universe. The star system that created 3I/ATLAS has long since evolved beyond recognition. Its original configuration dissolved through stellar evolution, planetary migration, and gravitational interactions with neighboring systems. Yet the chemical signatures preserved in this wandering fragment allow us to reconstruct aspects of stellar environments that existed when our galaxy was young and actively forming new stars at rates far exceeding current levels. We are, in essence, conducting paleontology of stellar evolution through analysis of interstellar debris. The parallel between stellar and biological evolution is striking. Just as fossilized remains preserve information about extinct biological species, interstellar objects like 3I/ATLAS preserve chemical information about extinct stellar systems. Both forms of paleontology reveal the deep history of complex systems through careful analysis of preserved remnants. This connection between stellar death and cosmic preservation touches on themes that appear throughout both scientific and philosophical traditions. The idea that death and dissolution at one level of organization create the conditions for new forms of complexity and consciousness at other levels. As you reflect on the stellar origins of the materials now sublimating from 3I/ATLAS, notice how this realization might affect your understanding of death and continuity. The carbon atoms in your body originated in stellar cores similar to those that created this ancient comet. Your existence depends on stellar death and transformation that occurred billions of years ago. Some philosophical traditions suggest that recognizing this cosmic recycling of matter and information can provide perspective on personal mortality and the continuity of consciousness beyond individual existence. While these interpretations remain speculative and lack scientific validation, they illustrate how astronomical knowledge can inform existential reflection. The study of 3I/ATLAS demonstrates how phenomena operating at cosmic scales ultimately depend on quantum mechanical processes occurring at atomic and molecular levels. The spectroscopic signatures that reveal the comet's chemical composition arise from electronic transitions within individual atoms and molecules. Yet these microscopic events carry information about stellar nucleosynthesis processes that occurred across light years of space and billions of years of time. This convergence of quantum and cosmic scales challenges conventional assumptions about the separation between different levels of physical reality. The same quantum mechanical principles that govern atomic interactions in laboratory experiments also determine how stellar cores synthesize heavy elements and how interstellar dust grains preserve chemical information across galactic distances. The recognition of this scale convergence has profound implications for understanding the relationship between consciousness and physical reality. If quantum effects provide the fundamental basis for all physical processes, including the neural activity that generates conscious experience, then consciousness and cosmos share a common quantum mechanical foundation. Some interpretations suggest that this shared foundation might allow for direct connections between conscious observation and cosmic phenomena, though this remains a highly speculative idea without scientific consensus. The possibility that consciousness might influence physical events through quantum mechanical pathways continues to be debated by physicists and philosophers without resolution. As you contemplate this convergence of scales, notice how it might affect your sense of connection to cosmic phenomena. The quantum processes occurring in your brain, as you think about 3I/ATLAS, operate according to the same physical laws that govern the stellar nucleosynthesis that created its chemical components billions of years ago. This recognition can produce what some traditions call cosmic consciousness, an expanded sense of identity that encompasses multiple scales of space and time simultaneously. While the mechanisms underlying such experiences remain mysterious, they appear to involve shifts in how consciousness processes information about scale, causation, and identity. As humanity's technological capabilities expand through projects like the Vera Rubin Observatory, we stand at the threshold of a new era in cosmic awareness. The prospect of detecting dozens of interstellar visitors annually will transform our relationship with galactic phenomena, from studying rare curiosities to conducting systematic investigations of cosmic evolution and material exchange between star systems. This transition from scarcity to abundance carries profound implications for human consciousness and our understanding of our place in the galactic community. When interstellar objects become routine rather than extraordinary, how will this shift affect our sense of cosmic connection and meaning? The democratization of cosmic discovery through improved technology and internet access means that increasing numbers of people will have opportunities to participate directly in the study of authentic samples from other star systems. Amateur astronomers, equipped with modern instruments, can contribute meaningful observations to international research efforts, while online archives and citizen science platforms allow anyone to examine spectroscopic data from interstellar visitors. This broader participation in cosmic discovery might represent an important step in the evolution of human consciousness toward what some theorists call planetary awareness, a form of collective intelligence that operates at scales comparable to the cosmic phenomena it studies. While this remains a speculative concept without scientific validation, the global coordination required for projects like 3I/ATLAS observation suggests that such collective capabilities are already emerging. Take a moment to imagine yourself as part of this expanding network of cosmic awareness. Your attention to interstellar phenomena connects you to a global community of observers, while your consciousness participates in the universe's capacity for self-reflection through conscious beings capable of studying its own evolution. The questions raised by objects like 3I/ATLAS will likely persist long after individual visitors have departed our solar system. Each interstellar encounter adds new data points to our understanding of galactic evolution, chemical distribution, and planetary formation processes throughout the Milky Way. But perhaps more importantly, these encounters continue to challenge our assumptions about consciousness, observation, and meaning in ways that extend far beyond astronomy into the deepest philosophical territories human thought can explore. As 3I/ATLAS continues its hidden passage behind solar glare, approaching the moment of maximum heating that will potentially transform its structure and composition in ways we cannot directly observe, we return to the eternal questions that have driven human curiosity throughout history. What is the relationship between consciousness and cosmos? How does awareness emerge from matter? What role does observation play in determining the nature of reality? As this ancient messenger prepares for its transformation behind solar fire, perhaps the deepest revelation isn't what we'll discover about 3I/ATLAS, but what it has already revealed about ourselves. We are the universe becoming aware of its own deep history, conscious witnesses to stellar processes that shaped galaxies before Earth existed. Whether this visitor emerges as a transformed comet or continues to challenge our understanding, it has already succeeded in expanding the boundaries of what we consider possible. In December, when 3I/ATLAS re-emerges from solar conjunction, it will carry the marks of its encounter with our star, potentially fragmented, chemically altered, or bearing new secrets from its hidden passage. But the questions it raises about consciousness, observation, and our place in the cosmic community will persist long after it departs our solar system. We are living at the precise moment when humanity can first recognize and study authentic messengers from other stars, participating in a cosmic conversation that spans billions of years and countless light years of space. Take one final breath and feel yourself connected to this ancient wanderer as it continues its journey through the fire of our sun. The atoms in your body share the same stellar heritage as the materials now transforming in ways we cannot see. You are simultaneously observer and observed, student and participant in the universe's capacity for wonder and self-discovery. If you found yourself drawn to these questions about consciousness and cosmic phenomena, I invite you to continue exploring how the very act of questioning reality might reveal